friends, and welcome to the Adventures of Blink. I am, of course, Blink, and you can find me on GitHub right here. Now, if you find this content to be useful or helpful or fun, drop me a like. Let me know that you enjoyed the content, that you got something out of it, that you'd like to see more things like it. And of course, if you're looking for more content just like this, make sure you click the subscribe button, and that way you won't miss upcoming episodes as they roll out. So this season, we're on a DevX deep dive. We're looking at common occurrences in the everyday lives of software engineers and finding things that will lead to bad experiences later and fixing them so they won't. Last week, we looked at a setup script. We started with something that was hastily assembled. It did the installation, but we saw some weaknesses in the way it was constructed. There wasn't any error checking. It made some really dangerous, assumptions about how things were in the environment. And in particular, we encountered a concept called idempotency, which is the idea that we run a script multiple times, we should always end up with the same result. Well, today we're going to move on to another software engineering practice that's often neglected, software testing. In much of my career, I've observed that testing is frequently treated as a second-class citizen. Tests are often completely missing. They're never even created. Or if they do exist, they're brittle and messy, and they're not well kept, and it takes a whole lot of maintenance to keep things the way they ought to be. So in this adventure, we're going to take a look at a broken test file and come up with some ways to improve it. First, we'll need to see the code that it's testing. Remember, this is sort of a contrived example, so it's pretty small and innocuous, but its purpose is to demonstrate a wider concept. So for today's example, we're going to use something called the board API. I found this online. It's a teaching tool that you can see there. It's for students of the App Brewery. But the upshot is the board API is a freely available API. It's rate limited, but there's no authentication required or anything like that. It's just you hit the thing, get a response, and you can do stuff with it in your app. I thought this would be a great way for you to be able to code alongside me if you're interested in doing that. You can, of course, go down in the description and hit the GitHub repository for this season's episodes, and you can go find the code to get this started. You should be able to run this just fine on your own box if you've already set up Python. And if you haven't done that yet, you can go back to previous seasons and see lots of setup instructions for how to build your dev environment. Anyway, what we're going to do with this, I've made just a little tiny bit of code here that we're going to work in. So this is our application, and you can see it's very simple. It goes out to an API, and it gathers some data, and it brings it back to us. And so I can actually come down here, and I can run Python get activity. And there it is. It comes up with the idea that I should configure two-factor authentication on my accounts. Good, secure suggestion for what to do if you get bored today. However, we would want an application like this to be tested in some way. We want to validate that our code is working. So here you can actually see there are some tests associated with our application already. We have a test for activity is string and non-empty, and we have a test that activity has expected keywords, and we would be like, hey, look, we have tests for our application. So if we have tests, why is this even a concern? What's wrong with our testing strategy here? Well, I've noted a few things in the comments that we can look through to get an idea for why this could be problematic. The first thing, here on line 6, I made a note, we're relying on the live API. You can see in line 7, we're calling getRandomActivity, which is the name of the method here, and it's actually going out and making a call to the API. Why is this a problem? Well, if we're rate limited, newsflash, that's one of the things that the board API does is rate limit. If it's down for some reason, if it's running slowly, we don't have any control over that. And so our tests will continue to fail even when our code is actually working fine and the problem is on the API side. We're not beholden to the API's, uptime responsibility. That's their problem to deal with. It's up to us to know that we have called it effectively and we're interacting with it properly, but it's not up to us to fix it if it goes down. And so relying on the live API for your tests gives you a false sense of problems, right? Because now you're making calls to this thing and getting responses back that may not be your fault. And now you're not testing your code anymore, you're testing theirs. Another thing is that these can be flaky. If the API returns an unexpected shape response, let's say that they add a new field to the response or something like that, and we're not prepped for it, then we may miss out on something. It may not be quite the right way to handle it. And so we would get errors based on the things changing within their system rather than within ours. We should be able to accept that, and we say, yes, we made a call out there, we expected to get a response back, those things happened, and we don't necessarily care about data issues when we're testing our code to see if it works. Another thing that we should be worried about is that we make assumptions about the content of random API responses. So in this other test, which actually continually fails, we're making an assumption that it's going to have certain content, and we don't have a way to test for that. What we want to do is stack the deck in our favor so that when we run the test, we know that we're able to see the behavior we want to see. Now, we may want to test what the behavior is if we don't get that, because we have like an error handling branch to deal with or something. But that should be something we control, not something that we just arbitrarily make a call to the API and hope we get a test of both. You know, if I'm testing whether these words exist, maybe there's a percentage of times that it will succeed and fail, but do I really want to roll the dice every time I run my testing suite? No, I want to control that behavior so that I know I'm testing it in a successful and an unsuccessful case. So those are some issues that we're going to try to work out. So remember, the goal of a good test is to always pass unless something that you changed breaks it. That's an important distinction. We talked about it a minute ago. I'm not testing the API's code. I'm not testing the API's data. I'm testing my code. Did it make the call? Did it handle the response? Those are the only things that it should be doing. I should not be concerned with those other things at this layer of testing. These tests should protect me from making changes to my code that break the behavior, not other people's code. If I write tests that can't consistently pass, it generates distrust in my test suite. And that encourages developers, myself and others who might be working on this code, to just ignore the test failures. And then we end up in a world of hurt. So how could we fix these tests? How could we make them better? So now it's time to start building the new test suite. I've called this after test, this file, just so that we have the before and after. I'll have to go into the before test and comment everything out so that it doesn't get treated like a test anymore. I don't want it to run in the future. I want to focus on just running the after test, but we'll look at that in a moment. Let's go ahead and get this built. So from unit test.mock import patch. And I'm going to kind of gloss over things here at the beginning, but we'll talk about them in detail as we build the tests out. The next thing I want to do is get the actual code that we're going to test. So from get activity import get random activity. Now that's interesting. Why did it not find that? Because I needed to add the extra paths in. There we go. Okay, so the next thing I'm going to do is I'm going to patch get activity requests.get. Now, if you haven't done any testing like this before, it might look a little weird, but what we're doing with a patch statement is we're telling the test suite that when we run the actual code in our method, if it finds this pattern, it's going to interject what we want into it rather than using what's already there. So we're mocking out or patching requests.get because that's the thing that calls the API. Remember in our original code, we can go look at that real quick. When we see requests.get, we're about to go to some URL. We don't want to go there anymore. We want to control the inputs that come from that. So what we're going to do in our test is say, when you see requests.get, pretend that you made the call that was made there and respond in the way that we have interjected so that you always get consistent inputs. So def test activity returns expected string. And we add a mock get to that. And so here we're actually going to simulate the API response. So we can make our code test everything except for that one little block that goes out to the API. And we're going to say, use our code, use our code, use our code. When you find that API call, skip it and inject this instead. So mock get dot return value dot status code. So think of an HTTP response. We're going to inject what we want, a 200. So it will always respond with a 200. It will never actually make the API call. This gets plugged in and takes over for the original code, just in the case of the request.get. So mock get return value dot JSON dot return value. So think about an HTTP response. It's going to respond with a status code and it's going to have content, right? And so we got the status code, that's 200, and now we're going to build the response. So it's always going to be activity, take a walk. Now, every time PyTest runs our test suite, whenever it's supposed to make an API call and get a random activity, it's not random anymore. It's always going to respond with take a walk. This allows us to test all of our code and leave the API call, and we just say, hey, this is what you ought to pretend the value would be. So the next thing we're going to do is activity equals get random activity. And now we have a response. Activity, the variable, should contain both the 200 and the activity JSON string there that says take a walk. So we're going to use assertions. We're going to say, I want to assert that this is an instance of a string. So an activity should always be a string. See, an activity should always be a string. And then I want to assert that the activity string equals take a walk. And so now I have the ability to do this. Now, if you want to get really fancy, you could actually change this so that you would have and you would probably do this as all caps, right? And so you could say that, and then you don't ever have to worry about whether you change the value in all the right places. So that would be a great way to think about doing this. Okay. Now, I said a minute ago I have to go back and block out. So I'm going to come in here and I'm going to do select all and tell it to make those comments. And now when I run PyTest, oh, I forgot to save this file. Now when I run PyTest, This is because I'm a goober and I pushed the wrong button when I was setting it up in here. I meant to put my test file inside of episode 3. And so PyTest couldn't find it because it wasn't in the directory. So now there we go. And I have a passing test in the after suite. And so there you go. I can actually confirm that regardless of how many times I run this, I'm always getting back take a walk. And that's because I don't actually make the call. I just pretend to, and I respond in a way that mocks the data so that it's available. It's a powerful technique and something you definitely got to learn in order to do good testing. All right, so let's add in another test here just to kind of give us a handle on some other things we could do with it. So now I'm going to patch the same thing. So this one is going to rely on the same kind of patching technique. And I'm going to do test activity handles HTTP error mock get. Okay, and this time what I'm going to do is let's imagine that the API doesn't respond. Well, I can't take down their API, so I don't have a way to test that. I can use the mocking in order to pretend that it's down, though. And so with that, I just do with PyTest raises exception match equals API is down. Okay, and in the same way, I could have done this, and I probably should. You should always get in the habit of making sure that your strings, whenever they're repeated like this, are made into constants so that you get to control. There. And so now I have a test that should validate that the API is down. So it mocks getting a side effect that says API is down, and that gets passed into the function so that when I make the call to get random activity and it does the request.get, it says, oh, I'm supposed to respond with a thing that says there's an exception that the API is down. And so now when I rerun my test suite, that passes as well. And so I can start to validate all of these things without ever using the API. So you might be asking yourself, why did we go through the exercise of doing this? It kind of feels unproductive, doesn't it? It's like, well, we just made things that test to make sure that what we expect is what's going to happen. And it doesn't, it's not a new feature to the application. It's not a bug fix that we introduced. It's just kind of there, and it doesn't make any sense on the surface. But it's really important work because having reliable tests means we can actually start to move faster. Here's how I want you to think about that. If we go back over here and start making changes to get random activity, and maybe we want to do other behaviors along the way, we want to ensure that it does something else alongside what it already does today, we can be certain that we haven't broken any functionality when we make those changes because our test suite will run immediately. And it doesn't matter what we change. It doesn't matter how we think about editing things. If the original behavior still needs to exist, the tests will pass unless we break them. And so we have the ability then to very quickly validate, after you've spent an hour trying to code up the new feature and plug it in and you kind of have it working and you're like, did it get there? And then you don't know because you have to go through this whole, extensive manual testing cycle. But with the test suite in place, it's as simple as boop, and now I know. Well, that wraps up today's adventure. I hope you're learning a lot through this experience, and I hope you're enjoying it at the same time. There's so much fun that can be had in software engineering practices that also make us better. So I can't wait to see you next time as we talk about the phantom dependency. Take care.